Hello बच्चों. So how are you? I hope you all are fine. Okay students, so can you see the figure? क्या है ये? Something poisonous, something dangerous. Yeah, they are carcinogenic, but they have very wide applications also and interesting application also. So today we'll start a new topic, cyanides and isocyanides. This is a topic of organic chemistry class 12th. Okay students, so you can see, I think this figure, something poisonous, something dangerous. Yeah, same atoms, opposite personalities. Why these opposite attitudes? Because if there is a flip in bonding, the compound will change. द कंपाउंड RCN है वो RNC बन जाता है, और RNC जो है एक फ्लिप बॉन्डिंग में, मतलब CN के जगह इफ NC विल बी देयर, द होल प्रॉपर्टी विल बी चेंज्ड. ओके, वो पोलार होता है, ये नॉन पोलार होता है. वो इतना स्मेली नहीं होता है साइनाइड, बट आइसोसाइनाइड इज़ वेरी स्मेली. ओके, एकदम ऑफेंसिव स्मेल होता है, ठीक है, और फाउल स्मेल विल कम. ठीक है, वी विल स्टडी ऑल दिस प्रॉपर्टीज. ओके, सो लेट्स कंटिन्यू विद दिस टॉपिक. उससे पहले चैनल को लाइक और शेयर और सब्सक्राइब कौन करेगा स्टूडेंट्स? सो काइंडली लाइक एंड सब्सक्राइब. तो चलो. Hello students, today we'll study about cyanides and isocyanides. They represent two pivotal functional groups within organic chemistry which possess very captivating properties which make them interesting. Earlier they were known for its potent toxicity, but yet they have some very important uses also, and it had wide applications which make them very interesting. Okay, so it is not only confined to the lab, okay, but they have very wide use in natural and synthetic chemistry. Cyanide compound are found in various plants as a defense mechanism. Okay, it is an interesting fact that in various plants cyanide compounds are there which help them in their defense mechanism and in metabolic processes of some microorganism also. And they are also, you mean synthetically, if we will see, synthetically they are used in agrochemicals, pharmaceuticals, polymers, etc. Okay, so these wide application make them very interesting. Okay, so we know the structure. I think let's see the structure. Here carbon RCN and here RNC. Okay, they are very poisonous here, so we have to be very careful in the lab also. Okay, they are carcinogenic in nature, so we have to be very careful during the use. Now structure. Here it is, you will see, this is an ambidentate ligand. Ambidentate ligand means it has two binding sites. Two binding sites. One is carbon and one is nitrogen. It can bind from carbon to the alkyl group as well as from the nitrogen to the alkyl group. In the cyanide, what is happening? It is binded, it is the linkage is through carbon atom. The linkage is through carbon atom. This is alkyl and this is carbon. And in isocyanide, the linkage is through nitrogen. This is your alkyl, R is alkyl and N is nitrogen. So this is the difference. Both are means the linkage is with triple bond. Okay, if you will see, R and C means both the carbon are bonded with single bond, but here a triple bond is there. So nitrogen will form triple bond with carbon, and here also it is happening when one coordinate bond is there. Okay, so you can see here sp-hybridization due to triple bond, here also sp-hybridization due to triple bond. Okay, 180-degree bond angle in both the cases, and nucleophilic character. Here some isocyanide I'll tell you later, means we will further move in the topic and I will explain you later. So what you have to remember, in RCN the carbon is the, means the linkage is through carbon. The carbon is the linkage atom where it is attached to the alkyl group, and here in isocyanide through nitrogen the linkage is there. Okay, so the linkage is through nitrogen atom with the alkyl group. Okay, so sp hybridization because of triple bond, 180-degree bond angle and nucleophilic character. Okay, now we will start with the IUPAC nomenclature. IUPAC nomenclature, we should know some rules. Okay, we should know some rules. Common name is you will see alkyl cyanide. Common name is alkyl cyanide. Means whatever will be the alkyl, that cyanide, like here methyl cyanide. And IUPAC name we will be counting will from here 1, 2. Okay, we have to count from this C also because this is the atom which is in the parent chain also. Okay, so ethanenitrile, the name will be now 2 carbon is ethane and nitrile. Okay, so this E we can neglect because ethane, it means ethane 1 nitrile only, so we will not put two vowels together. Okay, so ethane 1 nitrile, like this we will write. Okay, now here if we will see this cyanide, then propane nitrile, 1 2 3 like this. Okay, propyl nitrile, we will do some exercise. Now I pick name for cyanides. Let's see if I am writing like this, CH₃CN. What is this? This is, if I am writing the common name will be methyl cyanide only. If I am writing the structure like this, then the common name will be methyl cyanide only. But what will be the IUPAC name? IUPAC name we have to give the number. Now this will become ethanenitrile. E will not come, ethanenitrile. Okay. Now here again, if I will write ethyl cyanide. Okay. CH₃CH2CN or C2H5CN can be written. We have to give the number. In IUPAC name, we have to give the number of that carbon also, in which means the cyanide group is having that carbon, and it should be numbered. So 1 2 3. Okay, what is this? You will write propane. E will not come. Propane nitrile. Okay, propane nitrile. Ethyl cyanide, propane nitrile. Understood? Ethyl cyanide. But when you will write the IUPAC name, it will be propane nitrile. Okay. Here let's change the heading. Here I can write the structure, and here is the IUPAC name. Okay. Now let's see propyl cyanide also. I hope you can do propyl cyanide. Okay, students. You know propyl cyanide 3 carbon plus 1 C. Okay, this 3 carbon plus 1 CN. Understood? But IUPAC name, this will become butane nitrile. Understood? Okay, students. Now let's do one more. Now here the diagram is there, the name is written, we have to draw the structure. Let's see what we have to do first. 2-methyl propane nitrile, 2-methyl propane nitrile. What we have to do? First, this is the chain. We have to do 3 carbon. Okay. Now this is IUPAC name. So we will make this as CN. 1, 2, 3. Okay. Now in 2, methyl is attached. In the second position, methyl is attached. So what should be the name? 1 is nitrile, 2 is methyl, and this chain is propane. Everything is done. Now we have to give H atoms. We have to satisfy with H atoms. How many H will come? Here 1 bond is there, so 3 H will come. Here 2 bonds, 1, 2 and 1, 3. So 1 more H will come. Okay, so this is 2-methyl propane nitrile. Got it? Okay. Now if this is the condition, write the IUPAC name of the following. What we will do? We will give the number 1, 2, 3, 4, 5. Now this is pent. Okay, I am giving you all the hints. You have to compile everything. Pent. Then next is 1 is cyanide. Oh sorry, 1 is nitrile. Okay. Then what is 1-penitrile, and in 2 ene is also there. Pent. One more thing. 3 is methyl. Okay. In 3 methyl group is attached. In 1 nitrile is attached. 2 ene is there, and the name of the chain is pent. So what will be the name of the compound? First substituent you have to add 3-methyl. This should be capital. Okay, this should be capital. 3-methyl. Now this chain pent, then 2-ene. You might have done in class 10th and 11th. Okay, so just you might be knowing the word root and all everything. Pent 2-ene, 1 nitrile, 1 nitrile. Okay, so this is our name. 3-methyl pent 2-ene, 1 nitrile. Now here what we will do? 1, 2 and this is 3. So 1 is nitrile. Okay, 1 is nitrile. What are the information you can write? 1 is nitrile, and 1, 2, 3 no double bond, propane, 1, 2, 3 propane, 2, 2 dimethyl. 2 is what? Dimethyl. Now we have to compile all the 3. How we will write? I am writing here just little bit here. 2, 2, then dimethyl propane 1 nitrile. Propane nitrile also you can write. Propane 1 nitrile is also correct. Okay, now I am rubbing this all information. 2, 2 dimethyl propane 1 nitrile. Now here next one. This is different. 3-cyanopropanoic acid. 3-cyanopropanoic acid is what? If you will see here, cyano will be the substituent. Cyano will be your substituent. Okay. Cyano is your what? Cyano is your substituent group here. Now propanoic acid, this is actually one oic acid. So you have to make cyano as a substituent group because one main chain is there which is propanoic acid. Okay. So 1, 2, 3. This oic acid is there. Propanoic acid is there. Now in third group, now this will be treated as 3. 1, 2, 3. This will be what? Cyano. Now you will not count because it is a common name, like means cyano is written over there. So this will be our structure 1, 2, 3, and you have to satisfy it with 1, 2, 3. Okay, so 3 cyano propanoic acid. Okay, if it will be ethanoic acid, then ethanoic acid, what you will do? Ethanoic acid, only this. If it will be 2 cyano, then this cyanide will come here. Okay, 2 cyano ethanoic acid. Okay, 2 cyano ethanoic acid. This is 3 cyano propanoic acid. Okay. In 3 cyano is attached because nitrile we are not using, that's why we will write it like this, 3 cyano propanoic acid. Now isocyanide is also a little bit similar. Okay, but isocyanide common name is methyl isocyanide. But one more thing you have to remember, like if I will draw the structure like the CH₃NC, so methyl isocyanide, the common name will be methyl isocyanide. And the IUPAC name will be methane isonitrile, alkane isonitrile. Okay, this will be alkane isonitrile. So I am writing here alkane isonitrile. Alkane or methane you can write. Methane isonitrile. Okay, here E will not come. Methane isonitrile. Now the same case with ethyl also, ethyl isonitrile. If we will write like this, so what will be our structure? Our structure, I am drawing little small, otherwise it will be very mess. C2H5NC. Okay, here it will be ethane isonitrile. Now this carbon will not be counted here because N is also there. So whatever is this, you can write it like this also. This is 1 and this is 2. Okay, so ethane isonitrile. Understood? Okay, now this condition isopropyl, this is common name, isopropyl isocyanide. IUPAC we have to think isopropyl because this is the structure, that's why. Okay, we have to use our brain. Now what we will do, we will not give any one to this because our structure is only this, only one pay. You can see iso group is also attached and methyl group is also attached. So in one, what are the things added? One nitrile is also attached, sorry, isonitrile is also attached, and in one methyl is also attached, and the parent chain is what? Ethane, sorry. Parent chain is, these are the substituent. Okay, substituent, and parent is what? Parent chain is your ethane. So you have to compile this 3. Now what you will do, you have to write the name as 1-methyl ethane isonitrile. Okay, so what will be the answer? 1-methyl, you can write like this, 1-methyl ethane isonitrile, or you can write only methyl ethane isonitrile. You can neglect this one, methyl ethane isonitrile. One I have written because of your convenience. Okay, so you will not get confused. Okay, now we will go to the preparation methods. Cyanides and isocyanides. For cyanide we will take KCN or NaCN, but for isocyanide we will take AgCN. Why this is happening? Because in KCN is an ionic compound, completely purely ionic compound, which will liberate K plus and Cn minus ion. Okay, and due to this, dissociation of ion is very much possible. Cyanide is having a property, because it is having sp-hybridization, which makes the carbon more electronegative, and due to this electronegativity, the carbon is more nucleophilic also. The nucleophilic center is carbon. Okay, so K plus and Cn minus is easily dissociated, and what happens, as it is purely ionic, and due to sp-hybridization between them, 3 bonds are there, this electron will be located here. Okay, it will be localized here, Okay, understood. Due to resonance as well as sp hybridization. So this make the carbon center more nucleophilic. Okay, and the attack of alkyl, as it is plus, it can be easily on the carbon atom, or if you will say, this two will be attached easily. Okay, but in AgCN it is ionic, but it has some covalent character also. It has some covalent character. Okay, due to this covalent character, why this covalent character arises? Because it has a small size. AgC has a small size. Okay, and its polarizing power is very high due to means some characters are there, that is poor shielding of d electrons. That is another topic, it will be very vast. Otherwise I am just explaining in short that poor shielding effect of 4d electrons and greater Z effective Ag cloud shrink, Ag plus cloud shrinks, and due to that covalent bond arises. Okay, there is a difference in size, polarizing power will be high, and you know, according to the Fajan's rule, covalent character arises. Due to Fajan's rule, it give covalent character, and covalent character makes the dissociation of Ag plus and Cn minus difficult. Okay, and because of this, the electrons are not at all located at carbon. It cannot localized at carbon atom, rather it is more, it is making the nitrogen more nucleophilically active. Okay, preparation we will do, of course we will do it from cyanides, and for isocyanide we will use AgCN. Okay, so first method is from alkyl halides. So I have taken Rx. You can take anything, CH₃CL you can take, and then plus what we will take, NaCN or KCN, both we can take. Okay. So what will happen? You know what is happening here. This is plus and this is minus. Del plus, del minus also you can write. Here del plus, del minus you can write. So what happened? Now this becomes minus. So this will attack at the plus side. Okay, so this will become RCN plus this. In this case Kx will be removed, in this case Kx will be removed, and in the other case RCN plus NaX will be removed. Okay, so this is our product. In the next second we will see from amides. Here we will take SOCl2. Okay, SOCl2. So I am writing R C double bond O NH2. Okay, here also you can make the SOCl2 like if I am writing the way, if you want to liberate this O, then we can arrange it like this. Okay, now this SOCl, this is SOCl2. If you will write like this, you can remove many things, this H and this 2Cl. Okay, so this will form 2HCl plus this SO and this O. So this will form what? SO2. And what is left? R, C and N is left. R, C and N will form cyanide. Okay. Third we will do, understood? RCONH2, so SO2 is removed and 2HCl is removed. Okay, you can write like this also. Here also SO2 and HCl like this you can write. Okay, so I have written here, so I am not writing. From the third step is from aldoxime. Aldoxime means aldehyde plus hydroxylamine. Two words are there. Aldehyde we will take. Acetaldehyde also we can take like this. Here we will write H and here we will write O. This is aldehyde or acetaldehyde you can say, and plus hydroxylamine, that is NH2. I am writing, okay, and hydroxylamine NH2. Now just remove this H2O and join the other things. CH3, CH, then this double bond will be as it is, then N, then OH. Okay, now again what will happen, and this H2O will be liberate out, minus H2O will liberate, and CH3CN will be left. Okay, is in the presence of P2O5. Okay, dehydration will occur. Okay, now these are the three processes. Then if you will do the preparation of isocyanides, what are happening? Isocyanide first is AgCN. I told you what you have to take, Rx only, but it will be RNC plus AgX. Second step is carbylamine reaction. What is that? carbylamine reaction. The name is given, carbylamine reaction. The reaction is also very important. What is this? From primary amines. Okay. Primary amines will give this reaction, aryl and aliphatic both. Aliphatic both will give, but it should be 1 degree amine. Okay, it should be 1 degree amine. Plus what we will take? We will take KOH, Cl3 in the middle, CH, Cl3. This is chloroform because this is an important agent and a base. Okay, alkali I am writing. Okay, alcoholic KOH. Okay, now what will happen? It will form RNC plus 3 KCl will be there and 3 H2O will be there. Okay, so this will form, and this is very offensive smell. Very means that foul smell or offensive smell will come. Okay, so this is one of the important preparation, carbylamine reaction. Okay, so isocyanide, for this too we are doing. Many properties are there, many more things are there, but we will do in the next properties. Okay, these are generally colorless liquids, and lower members are soluble also. Lower members 1 to 15 members are soluble in water. Okay, and as this has a polar bond. Okay, the bond is polar due to CN triple bond and electronegativity. You know, this is C is very electronegative, so this is polar and this is non-polar. Okay, this polar character gives many properties like solubility is more, okay, and high boiling points also. This is not low, this is high in comparison to, if I'll compare it with isocyanides, their boiling point is low, BP is low. Okay, and these have high boiling points. Extremely toxic. Cyanide is extremely toxic. These are also toxic, isocyanide, but less toxic than cyanides. Isocyanides are less toxic. Okay, these have means pleasant smell, or you can tolerate the smell. I am writing pleasant smell. What is this? Pleasant smell. But these have very unpleasant smell. You cannot tolerate offensive smell. Okay, very offensive strong smell you cannot tolerate. Okay students, so polar, non-polar, okay, due to polarity, due to CN bond, and this polarity gives solubility and boiling points also, high boiling points also, but this is non-polar, so that's why the character changes here. Okay, and here these are extremely toxic. These are also toxic but less toxic than cyanides. Okay, and lots of applications are there. Okay student, bye bye.